Hello everyone, welcome back to While True Learn. Let's jump straight into the next task, optimize roadway traffic. Hello, we are repairing the road surface in our city every day. Not surprisingly, it generates some problems with the road traffic. We ask you to write a pathfinding system. Okay, we got more deep news. Math data representation. In many cases, data is represented by obvious parameters, gender, age, salary, or distance to the nearest fridge in meters. This kind of data is suitable for any human being. Perhaps you're already familiar with the concept of correlation, which is also a fairly good parameter for analysis. People skilled in using simple mathematical dependencies are called analysts. Truly hardcore mathematicians go even deeper and describe data with distributions or even, oh boy, conditional probability distributions. Those principles cannot be explained without whiteboard and a math degree. This is where machine learning steps in, and sometimes algorithms are capable of finding dependencies that couldn't be even imagined by the brightest human mathematicians. Okay, this is just sorting shapes. Sure, I could just do a random forest again. Doing this, but okay, it has to sort 45, and yeah, that's not going to be fast enough. So I mean, we could use the decision tree shape. We just do the same thing we usually do for colors. So squares, squares, and then circles go here. Squares go here, triangles go here. It's the same setup we usually do for colors, but now we can do for shapes as well. Okay, not fast enough. Okay, we can always parallelize it. I don't think there's a way we can do it faster, because out of all the things that sort shapes, the decision tree is the fastest. Sift is slow, random forest is slow. Yeah, 3 out of 7, so yeah, we can certainly just make it parallel. And we can also replace all of this with a random forest, and that'll be fine too, but we don't need to do that. Okay. Accept. Alright, we got another big branch this way. Classified mail. Classified mail number 648232. Hello, the contents of this message is classified by the FBI. We have received information that someone had created a face recognition system for the KGB. Now our agents are facing certain difficulties in their daily operations. We need you to create a system that can surpass the KGB technologies. Okay, that's getting scary now. Okay, just red circles and just blue triangles. Alright, that seems okay. So we'll sort by color first, because sorting by color is faster than sorting by shapes. And then once we have the colors separated out, we can then do decision tree. Yeah, it would be nice if we had the sift, but if we don't have that, then we'll just do a random forest. We can also do 2 layers of decision trees, but why bother if we have random forest? Red circles go there, and then another one for the blue. Blue triangles down here. Okay, not quite fast enough. Oh, right, okay. Since we only need 50% accuracy, we can we don't need to sort the shapes perfectly. So up on the red, we can do something like this. So red will come in with half of the squares, but that's okay because if it comes in with half the squares, it's going to be about 66% accuracy. So that's good enough for this. And then down here, blue triangles, we need 75% accuracy. So 75% accuracy, we can't just mix in half of the other shapes because 66% accuracy is not as good as we want. But we can use that trick to swap the colors here and use this trick to parallelize processing blue. So now if we use two random forests in parallel, blue, blue, green gets trashed, and then we're going to, maybe just blue triangles go here, blue everything else get trashed, and then we're going to process the two lanes in parallel. That should be much faster. Great. Okay, Visa Center. Visa Center of Krakozia. Good day to you. This is the Visa Center of Krakozia. Sadly, your visa is not ready yet. However, the background you've mentioned in your application form made us want to offer you a job opportunity. We want to improve the efficiency of our center. An algorithm that could sort applications by the marks on them would do the trick. If we'd have this done by a machine, anyone could apply for a visa in a matter of minutes, instead of spending half a day at the visa center as they're doing now. Okay. So this is another breakdown by colors and shape. So if we do it by color, then red divides by circle, green divides by triangle, and blue divides by square. So let's do the standard sorting by colors. Okay, and then we have the most green items. So I'm going to put green in the middle so we can parallelize that for a little bit of extra efficiency. Okay, so red, I'm just going to do random forest again. That seems to be the most straightforward way to pick out shapes. And then, we don't need a trash can. Okay, red, circles go here, everything else go here. Green, circles go here. Triangles go up. Same thing down here. And then blue, squares go here, everything else goes up. Test. Yep, perfect. It's so much easier with the random forest because you can do all the shapes at once. I'm sure there are tricks for doing that using the decision tree, but we don't need that. Police technology, greetings to you. We are from the police. Don't worry, we are not going to press any charges yet, but we could use your help. Our analysts are working on improving our picture recognition system. We need to improve the quality of pictures in order to be able to distinguish all the details. Enhance. But we're kind of stuck. We would also like to improve the color restoration system and combine these two so they could work together. Can you help us out? Sure. Okay, this is just more sorting by colors and shapes. Okay, we only have green squares, okay. And then the blue triangles only go here, so that's 20 out of the 55 we need. Red triangles only go here. Red triangles is 15 out of 25. So I'm thinking maybe split the blue circles. So we have 15 red triangles going in here, and then half of the blue circles going here, the other half of the blue circles going here. Okay, blue triangles, we have 20 out of 55, we still need 35. Out of the other ones, we don't have enough from either source, so we're gonna have to share some of these. And it looks like we need to distribute some of these. So if we have all the red circles and half of the green squares, that'll be enough for this. It'll be 25 plus 15. That's 40 plus 20, 60. Yeah, 60 is enough for 55. And then all the red circles are gone, but we have half of the green squares remaining. So that's 15 plus half of the blue circles. Yeah, that should be enough. So let's go over that again. Okay. Red triangles go here, red circles will go here. All the red circles go here, none of it goes up there. Green squares we're going to share between the two sources, blue circles we're going to share between the two sources, and blue triangles go here. That sounds like a plan. Okay, let's go by color first. Now which one? I think I might want to put blue in the middle. Yeah, let's put blue in the middle for that extra bit of efficiency. Okay, now red. What we're doing is red circles and triangles we're concerned with. Let's do that sweet, sweet random forest, because that makes everything easy. Okay, red circles we said are going to go down here. Red triangles go here. Red squares we're going to throw away. Now blue, we also need the random forest. Actually, we don't need that right now. Blue circles. Right, blue circles we're going to distribute. But we have another lane here. So over here, the circles I'm going to go assign to the other output. Blue squares get trashed, blue triangles go down here. And then we're going to copy this. And then blue circles we're going to distribute to the second output, just to balance things out. And then green, we are going to split between output stream 0 and 4. And for that, we can do the any trick for a quick way to split the numbers. Okay, I think that's right. Okay, this one's just a little bit slow. Just a little bit slow. 8 out of 21. Okay, we have enough space. Go ahead and balance that. Double the speed. Perfect. Release. Okay. Next one we have fast data sorting. Good morning, we have a scientific satellite that aggregates data from our geomagnetic researches, but we need to put it down and launch a new one to the orbit. Can you help us extract and process the data from the old satellite? Okay. This is just different colors, different shapes. Yeah, we'll just do the same thing we've always been doing. And these have the same numbers, so it doesn't seem like it matters which one we put in the middle. gonna do random forest again because they all require 100% accuracy. Blue, green, red. Red circles go up. Red, everything else get trashed. Green squares go here, everything else get trashed. Blue triangles go here, everything else get trashed. Okay, that was easy. Okay, it looks like we got another story segment coming up, so we just have 2 startups remaining. So let me save the game. Okay, high-tech cars. Hello there. We are writing you on behalf of T Motors Company. As you certainly know, we are famous for our high-tech car designs. We receive all our parts from 2 manufacturing plants along with tons of information, and things often get messy. As a result, we make mistakes and production rates drop. Help us sort it out with your algorithm magic. We are ready to offer you a share of profits in return. Alright. We're investing 4,000 this time. Okay. Just another mix of stuff. We have all sorts of different sources. Yeah, we're gonna have to sort these shapes properly. I don't see any obvious ways to just put one of the inputs directly into the outputs. Okay, so let's go by color. We've been doing this a lot. Okay. Green squares, we have lots and lots of green. Oh, actually, you know what? Why am I doing that? We don't need that. Just red and green. We don't have any blue here, so there's no point trying to sort them. Okay, and then red we just need to pick out the triangles. So we can actually we can do a sift here. We just need to pick out all the triangles, which we don't want, and everything else can go into one of the outputs. So yeah, this is a startup. We don't have any output quotas, so we don't need to worry about which output stream we put the shapes into. We just need to put them somewhere with correct accuracy, and that's all we need. Okay, green. Green goes to either one. That's okay. And then the other one, we're gonna have to sort by shapes properly. And in this case, maybe green in the middle. Okay, green. So we're actually going to throw away the vast majority of all the green items, right? So I'm thinking, do we even care about the 5 green squares? Because that's a super tiny number and it might not even be worth processing. So maybe we'll just throw away all the greens. And then we'll put blue in the middle because we need to process more of those items. So I'm just going to throw away all the greens. I don't care about this output. Most of the greens are useless anyway. Red. Okay, red, we just need to throw away the triangles. And because we only have 2 shapes, we can use the decision tree, which is faster. Red squares, red circles can go wherever. Red triangles get trashed. Blue is the squares. So we have circle and square. Blue circles can get trashed. Blue square go here. We make another copy for the other lane. And green we are already throwing away. So let's test that. Yeah, we're not gonna get any items over here because we're throwing away all the green items, but I don't think it matters. Like the startups, it doesn't require us to fulfill all the output streams, it just requires, oh, this one is doing something wrong. Ah, we're getting blue, oh sorry, yeah. I forgot to filter by shape here. So, decision tree, the sift. We need a sift here. Well, the squares go here, and then everything else doesn't matter. Yeah, as I was saying, it doesn't have any quotas for the output streams. We just need to get the accuracy right. And we just need to process the vast majority of items, make sure nothing gets stuck. Now this one is getting stuck. So I think I'm going to parallelize these. Okay, so for this, we can do the any trick so we don't use a balancer. Let's test that. Okay, the queue here is still building up a little bit, so maybe we want to parallelize that again. We have plenty of nodes, so the number of nodes is not an issue. So now we have a four-way split to process all the green items, because yeah, we have a significant amount of green items compared to everything else. So this is going to get split 4 ways and processed all in parallel. In fact, you know what? Now we can assign some of these to the other output stream. Not that I think it matters, but it looks nicer when all the output streams receive something. Okay, our accuracy is doing good. Everything seems to be okay. Nothing is getting stuck. Nothing has an outrageously big queue or anything. Okay, I'm gonna call that good. Release. Alright, let's see what we're doing. We're making money, yeah, that's good. Okay, we have new users coming in. This is gonna be a bit of a pain to patch. Okay, see what we can do. This is a lot of stuff. I'm gonna put a balancer on each one. Okay, and this one's huge. Oh my. Okay. Whatever, we'll just balance it. Okay, let's test that. Now we should be going at double speed. Okay, still seems okay. Let's patch. Okay, yeah, now we're handling all the users. No, users are piling up again. I'm just gonna keep it this way because, as I said previously, I don't think the startups let you parallelize too much. So if we put more balancers in there, first of all, it's going to get really, really messy. But then it also costs more money to run the startup. And I don't think we're going to get that many more users handled. Okay, wow, this one is getting a lot. We already have 48k. and it's still increasing. Oh, whoops. It's still going up. This is crazy. Look at that, we're already 100K. This is not gonna stop. The balance is over 1 million now. And we're getting 162K. This is more money than we've ever had before. This is crazy. Okay, now it's starting to go down. Alright, yeah, I think that's it. I don't think we're gonna do any more. This is gonna start going negative, yeah. I'm gonna just cash out right now before the end of the week, so our balance doesn't go down again. Okay, we have huge money. Alright, let's get some more stuff. The U phone, buy it and be cool. Plaid shirt, be like a hipster. President armchair for the best dictators of the world. Okay. Hardware, micro stick router. Micro stick. Increases data transfer speed. Have an SSD. Increases a lot of stuff. We still have 220K left. Okay. We can easily afford this now. Wasteland helmet. Careers outfit. We have bought everything we can buy. Oh, look at my hair. This is great hair. Here's my phone. Here's the raccoon again. Alright. Let's go to... Let me save again. Let's go do the next startup. Soap making. Soap making business. Hey. We created a soap making startup, yet we need some help in another department. We've established a, let's call it, unofficial competition to determine the best porters for our business. Now we need a programmer who will write an algorithm which will allow us to decide who will compete with who based on their weight and other physical traits. And the most important part of the deal is you do not talk about it. Okay. Let's join the startup. Okay, I mean the output streams look complicated, but as I said, we can just ignore some of the output streams. So, and the fastest way we can do this is with a decision tree. So, we can do circles and squares. And circles with some triangles can go here. Squares with some triangles can go here. And I think that's all we need, because they don't have quotas or anything. We don't need to put everything in every output stream. Decision tree shape, this is the fastest module we can use. So maybe we could always balance it. But I'm pretty sure we can just use this. Release. Uh-oh. Do we need more users? Nope. We need to patch. Okay, balancer might be just unnecessary. We're just gonna do that. Patch. Okay, we're not satisfying all the users. Doesn't seem like it's working at all. Yeah, this is negative. That's why we save. Okay, soap making, drawing. Yeah, so I was pretty sure this would work. Circle, square with some triangles. Okay, see, that's weird, right? Because we weren't making money before, but now we're making money. And we're getting users. Yeah, now we're making money. That's weird. Okay, I'm not even gonna bother parallelizing it anymore because we're not making a whole lot of money. We're just making a little bit, and I don't think the increase in users for having a balancer is going to help that much. Or is it? I'll try it for one day. Okay, that's significantly more. Okay, I guess we'll keep it like that. Yeah, see, this is weird because the last time when we failed, we had exactly the same setup, right? It's just two decision trees, and then we had the balancer, and we were doing the same thing. But for some reason, we were losing so much money before, but now it seems like we're making money again, so I don't know how that works. Okay, our users are going down, so I'm thinking we can go back to the one node setup so we don't burn too much money on the balancers. Okay, yeah, see, our money is going up again. We can go for one more day, and then it's a positive amount, cash out. Alright, anything new we can buy? Nope, that's it. And we have done this section of the game. Improved recognition of cat emotions is 100%. Next time we come back, we will get another story segment and we'll move to perceptrons again. So this will be it for this episode. Thanks for watching, hope you enjoyed, and see you next time.